In this problem, we are going to find out the resultant of 6 concurrent coplanar forces which are acting at the center of a regular hexagon towards its vertices. The magnitude of the forces are 1 Newton, 3 Newton, 5 Newton, 7 Newton, 9 Newton and 11 Newton. These are the 6 forces acting at the center of the regular hexagon. To find out the resultant, the equation we are going to use is resultant R is equal to square root of sigma h square plus sigma v square, and the resultant's inclination with the x-axis is theta equal to tan inverse sigma v divided by sigma h. Now to find out sigma h and sigma v, where sigma h is the algebraic sum of horizontal components of all these forces and sigma v is the algebraic sum of horizontal components of all the forces. To find out the components, horizontal and vertical components, we will draw these forces as a vector diagram like this. So this is the two horizontal forces, and I will draw the vertical axis like this, These are the other forces. That is, this is 9 Newton, this is 3 Newton, this is 5 Newton, this is 7 Newton, and this is 1 Newton, and this one is 11 Newton. So we have a total angle of 360 degrees at this point. So in between the forces there are 1, 2, 3, 4, 5 and 6. 6 angles are there. They like this. The angles are 1, 2, 3, 4, 5 and 6. These are the 6 angles, and the value of these angles will be, how can we find it out? As this is a regular hexagon, all these angles or these lines will divide. These lines will divide. That is, those three lines will divide, or the diagonals will divide the the center or the 360 degree into equal angles, equal parts. Therefore, the total angle is 360 degrees, and there are 6 angles. Therefore, each angle will be 360 by 6 equal to 60 degrees. Therefore, these angles are, each angle are 60 degrees. 60 degree, 60 degree, 60 degree and 60 degree. These are the angles. Okay. Now, to resolve the forces into different components, we will draw the axis, then we will show the forces. Here we have one 5 Newton, okay, and we have the components of 3 Newton along horizontal and vertical component. The horizontal component will be like this, vertical component will be like this. So the horizontal component of 3 Newton will be like this, and the vertical component will be like this. That is, this will be 3 cos 60. It is plus, this will be 3 sin 60. This also will be plus. Okay. Then the second horizontal force is like this, 11 Newton, and the 1 Newton force is acting at 60° with the negative x-axis. Therefore, its components will be like this. So this is 1 cos 60. This will be 1 sin 60. That is 1 cos 60 and 1 sin 60. Here 1 cos 60 will be negative because it is acting from right to left, and this will be positive because it is acting upwards. Then for the 9 Newton force, we have the components like this. This is minus 9 cos 60 because this angle is at 60° with the horizontal. So this side will be the adjacent side and that will be cos component. So it is minus 99 cos 60 and this will be minus 9 sin 60. Why this is minus? Because it is acting in the vertically downward direction. And the last force, that is 7 Newton, acting in this direction. Its components will be like this. This will be 7 cos 60. This will be 7 sin 60 and this is minus. So these are the components of the forces acting on the at the center point of the regular hexagon. Now we will find the value of sigma h. So sigma h is the algebraic sum of all the horizontal components of the forces. Okay, so we have how many horizontal components? 5 Newton and 3 cos 60 minus 1 cos 60 minus 9 cos 60 minus plus 7 cos 60. These are the horizontal components of the forces. Now sigma h equal to, we will write sigma h is equal to, how we will write? We will find the algebraic sum. So first force is 3 cos 60, it is plus cos 60 minus 1 cos 60, or it is cos 60, again minus 9 cos 60 and again plus 7 cos 60. So when you calculate this, you will get sigma h equal to minus 6 Newton. Then when we find out the vertical component and algebraic sum of all the vertical components, sigma v equal to, here for the first force, that is a 3 Newton force, the vertical component is plus 3 sin 60 plus 1 sin 60, then minus 9 sin 60 and minus 7 sin 60. These are the vertical components and it is the algebraic sum. Out of these 4 components, 2 are positive plus and the other 2 are negative. When you calculate this, you will get sigma v equal to 10.39 Newton. 10.39 Newton. Now these are the components. Now we need to find the resultant. Resultant R equal to square root of sigma h the whole square plus sigma v the whole square, that is minus 6 square plus 10.39 square, its square root will give you the value of the resultant, the magnitude of the resultant, and that will be 12 Newton. This will be the magnitude of the resultant. To find out the angle, theta is equal to tan inverse sigma v divided by sigma h, where sigma v is 10.39 divided by 6. We need not consider the minus sign because we will be drawing it from the x-axis, or we will be showing the angle from the x-axis. So this will give you theta is equal to 60 degrees. Theta is equal to 60 degrees. Okay. So when we draw, if we draw the resultant as a vector diagram, it will be like this: 12 Newton, that is minus 6 and 10.39. The horizontal component, the horizontal component of the resultant is minus 6. So it is in this direction. This is minus 6, and this will be 10.39. Therefore, its resultant will be, how to draw the resultant? By constructing the parallelogram and drawing the diagonal. This will be the resultant, and it is 12 Newton. And this angle is 60 degrees. So this will be the answer for the problem. That is the resultant of those six forces which are acting at the center of a regular hexagon towards the vertices. Okay.